Hi, this is a video continuing a previous one where we looked at using SUMA to display ROIs and overlapping them, looking at how we can see the ROIs as color panels with opacity less than 1 so that we can see the overlaps with different colors with and without contour lines as well. In the first case, we looked at doing that all in the GUI, loading the data sets, selecting color bars and things like that. Now we're going to look at doing this all from the command line, what's called driving SUMA. So in the previous video, we drew 3 ROIs and we turned them into NIML dsets. They were called ROI 1, 2, and 3. And maybe for the moment, let me just run SUMA just to refresh for someone who might have missed that video. So very quickly, the ROIs that we drew, if I load them, load dataset ROI 1, ROI 2, ROI 3, and can display them all and use a color map for each one. So one was blue. Well, anyways, I set the color, let me just set the same color maps as before. So one was amber, data set 2 I think was blue, and then the other one was red. Okay, so these are the ROIs that we're looking at, and I could turn down the opacity on each one, and then we could see the overlap. Okay, there. So this is what we had before, and we also added a parcellation data set, but these are the ROIs. Okay, so all these things that I'm doing here, opening, selecting, choosing a color bar, and that we can do from the command line with what's called driving AFNI. So I'm going to open up a text file that you should have a link to on the YouTube channel, and also from the AFNI tutorials, there'll be a SUMA display option. So now let me open this. And there are a couple different scripts here. I'm just going to open one, do 00. So the most basic example. And so this, we'll just walk through this a little bit just to get a flavor of the options, and you can see what needs to be done and what are some. This one is a pretty basic command line. The other one has a little bit more fancy options. So I'm just going to set the prefix because I'm going to automatically take a picture of the SUMA window. So the prefix for the output JPEG will be this. This is something that's good to note, that when AFNI and SUMA talk to each other, or when we're kind of communicating with either of the GUIs, they use the ports. And sometimes it can be useful to specify a port number for each of these, so that if you have multiple SUMAs open and now you give a drive SUMA command, how would the terminal know which SUMA GUI to send your command to? It's because you basically defined a channel that you're talking on. And so in the beginning of the script here, there's a program in AFNI to find an available port, and then that number becomes the port number for everything in this script, because I'm going to use NPB, which stands for number port something. I suppose I could look it up, but that's too much work. Okay, so the initial thing that we're going to do is open up SUMA, just like I did actually with that T-shell run SUMA script. That run SUMA script actually just contains a command like this. So the first thing we do is open up SUMA, and something to note is with this script, everything will be done. It'll look as if someone's opening up the GUI so that we can see it, and then these things will happen in it kind of in real time. So this is something that you can only run this script on a system where the GUI can open up. So you need an X server to display things. So I'm running this on my own laptop. If I were logged in remotely on a different computer, I would need an interface to open up an X terminal there. Okay, but anyways, the first things first is just like we did in the initial case that I did very quickly just now. I ran a command like this. I ran it with with this, but you can just see here that that command contained one very similar to this. I just added the NPB basically so I can communicate on the ports. Okay, then this sometimes happens in scripts for SUMA. For more complicated things being done, sometimes it's good to add a little delay before you do another command, just to make sure, or to have a better chance that initial one finishes. So that's what these sleep commands are for. This is a sleep for 1 second. Then we're going to use basically drive SUMA to provide everything that we were doing with key presses or button clicks in the previous case. So we're going to drive SUMA on this port number, and we're going to say basically hit control left. And if you remember, that will show you a nice sagittal view. Then I'm going to open the controller, the surface controller. Then I'm going to do this series of things. So dot and dot moves us through the list of available surfaces in the specification file. So I know from these are the kind of things, setting these up really, usually with the way I do this is I do it once in the GUI, and then I kind of keep track of what I do, and then I make the commands out of it. And that way I know that the 2 dots gets me to that nice flat surface. These key presses, F3, 4, 5, and F9, these turn off other display features like the location button and the crosshairs and things like that. Just sometimes when you're saving an image for, let's say, a publication, you don't want those. Okay, so those are all those key presses submitted via the command line. Then what I'm going to do is I'm going to do just what I did in the GUI. I'm going to load a specific data set its opacity, choose how to display it, in this case a filled color contour. This turns off that one only button so that more than one thing would be displayed at once. So this means one only, and N stands for no. And this will set the color map, the red monochrome. Okay, so that's everything that'll happen for this data set. And that's, if you recall, everything I did just with button presses and key presses before. Then I'm going to take my next data set, ROI2.niml.dset, and provide a very similar set of commands, just one with blue monochrome is basically the only difference. And then for dataset 3, again, something basically the same and with amber monochrome. Fine. And then the only thing that's left to do is to take a picture of it, which is the control R. Here I have a control left here because anyways, sometimes I put this in a loop, so I'll go control left, control right, axial sat. It just depends on what you're trying to look at. So this line isn't really necessary, but I won't charge you any extra. Okay, let's see what this does then. If I run tcsh do 0, 0. Okay, so text in the terminal opens up the controller, starts displaying things, making them transparent with 0.5 transparency or translucent. And there should be an image saved here called that. And if I open that up, so AFNI open that image, there is my image. And this is something that I think we mentioned in the earliest SUMA videos, that the way the image is saved is really something like a screenshot. So if you notice when I opened it, it was the same size that it had appeared. And so it's very small, which means if I were going to display this like on a poster and I wanted a big one, now it looks like this is kind of a early Mario graphics type thing. So we may have fondness for earliest Mario video games, but that may not be what we'd want our image. So if we were really doing this, we may actually want a larger view panel. So if you want essentially a higher resolution image, what you do is you open up SUMA bigger, and so then when you finally display it at the real size, it has smoother contours and less pixelation like this. Okay, but anyways, proof of concept. I said that everything we did in the first case to save the image by button pressing, we could do from the command line, et voila, here it is. Okay, so this is hopefully pretty understandable. It just takes a while looking up what all the names are for these different options and things like that. So the drive SUMA help file has all these types of things, and there you have it. I'll note that I've also got here just a slightly more souped up example. So why don't we just quickly go through that if you're interested. And now what I did is, because there was a lot of repetition in that early script, so I made an array of the variable names and the color bars just so I can loop over them. Anyway, so this may be of interest more as T-shell, but hopefully it's not confusing. This means define an array of these things and an array of these things, and that'll be useful for just simplifying the programming later. This if condition just makes sure they're the same length, because I'm going to need one for one. Okay, I mentioned that if we want to have a kind of nice, effectively higher resolution image, one thing we can do is just open up our SUMA window bigger, and so when we save the image, the screenshot, it's effectively a higher density of information. So in this case, what you can do is you can set an environment variable in your SUMA, and I think I actually forgot to show that earlier in the first SUMA video. There's a .suma rc file, and this has a lot of environment variables just like the .afni rc file in your home directory where you can set things. So these are set kind of semi-permanently. If you want to set something as a one-off in a script, you can just say set environment variable, name of the environment variable, and then whatever information. This, as it says here, the first two numbers set the corner, the X and Y coordinates of the corner, and then you set the window width and window height. I don't know why this says window width Y is the height Y. So this will be a little bit bigger. And also you can set the auto record prefix to whatever you want. I think this is probably what everyone will choose, certainly for publication, but there you go. The beginning of this is the same as before. Find an open port number and then claim it, and then open up the specification file of all the surfaces and this surface volume to provide coordinates. Same as before. Look left with the hemisphere, and then open up the controller. These are all the same key presses. This time I added actually a few more of these. Capital Z's are for zooming in. So we've made the brain a little bit bigger. We can also kind of zoom in. And this is a little funny thing that I note up above. When you set the window bigger here, if you notice I set it to 801 width. I noticed when I was setting this up that if I just set this to 800 and did nothing later about the width of the window or anything like that, the brain was a little bit off center. But if I could just tweak or adjust the control panel, for example, like this to the control panel, then it recentered. So yeah, so that's a quirk. It's something we can kind of dig into more at the programming level, but anyways, this is just a small quirk that I describe here. So I actually want it to be 800 by 500. So what I'm going to do is set it to be 801. And the reason why I set it to be big is so that when it opens up and then it puts the surface controller, it doesn't open up small, put the surface controller here, and then get bigger so that it's covered by the surface controller. So there you go. Hope that made sense. I'm not sure it made sense to me. But the next thing we do once we have our panel set up is now to loop over all the data sets and color bars. So this means start a counter going from 1, counting by 1 up to the number of files or the number of elements in this array up above, which is just 3. So this variable will be set 1, 2, 3, and then it'll pick out the first data set and the first color bar and then do something with each of those. Okay, and this was just because so much of this command was the same for all of these. The only things that changed were the name of the file and the color bar. There you go. And then at the end, I'm going to show something that in the first video about going through the GUI view that I had done, I opened up this data set, which is the parcellation from the 2009 atlas for the left hemisphere, and displayed its contours, so that you may want to display your ROIs as filled in things, and maybe have the anatomical ROIs as contour references, just so you can say this overlap occurs in this anatomical region or something like that. And something that's worth noting here and is not to be overlooked is there's a lot of files output in SUMA, and some of them have this prefix std141, some have std60, and some of them don't have either of these prefixes. You want to make sure that you keep the same family of ROIs so that the index number and the indexes, the index labels or the index values refer to a consistent set of nodes. This means the standard 141 set of surfaces. The standard 60 is a lower resolution. This standard 141 basically matches on to well with a data set that would be acquired volumetrically at 1 millimeter isotropic. The standard 60 one corresponds more to the standard EPI spatial resolution. So anyways, if you notice here, this is the standard 141. These ROI dsets, you don't see it there because I drew them and I didn't give them that prefix, but they were drawn on the standard 141 mesh. And if you notice up here, I loaded in the standard 141 specification file. So you just want to make sure that these are consistent there. And even though my ROIs here don't have that std141, that was just my laziness in when I named the files. I probably should have called this std.141.roi1, but there you go. The explanation for me to explain it probably took longer than if I had typed it, but that's life. Okay, so it opens up that as well, and then it will take an image too. So let's try running do 01 then. So now if you notice the panel's a little bit bigger, it's zoomed in, it displays that, and it displays the contours of the anatomical regions now, as well as the 3 ROIs that I drew. And it should tell me that I have this image here. AFNI open that image. Ta-da, it's there. Okay, and if you notice, this image is larger than before. It's as large as I had set it to be here. If I were making something really for a publication right now, I might set this to be even a larger number and then take that snapshot, having a nice large screen, something that's really big. But anyways, as I zoom out here, you notice it doesn't look as pixelated as before. It's still probably not as super nice as it could be. But anyways, it's a higher resolution because I set the panel size larger. Okay, there you go.